So we are going to discuss AB type. So if you remember yesterday what we did, HCP, then there was upward triangle, downward triangle. We put atoms on upward triangle. This got converted into tetrahedral voids made by layer of A, and then this got converted into octahedral voids. And then we saw there was a new tetrahedral void that was made by layer B, tetrahedral voids of layer B. And when I put atoms, if I put atoms here, it is not useful. So I put atoms here on the octahedral void. I got ABC type that we have already discussed. When I put atoms on the tetrahedral voids of layer B, I got AB type of structure that we are going to discuss today. Now, when we are going to discuss the AB type, so first of all, what I should do, I should make a packing. Okay, just give me some time. I will make a packing for you guys, and then we will start discussing about the AB type. And then I will be putting up a layer of B atoms. So let me take a few atoms from here. Make it red and put it on this layer of B. Now again, I will be covering some voids, which are these voids. And in order to cover these voids, I will be adding one more layer. I cover this, I will again get the black layer here. Okay. So now I can take any set of atoms. So this is the packing that we had. I can take any set of atoms. So what I will take, I will initially, I will start with the black atom like this. I'll have 6 black atoms. Yeah. We'll have 3 red atoms. Then again the black atoms in the next layer. So if I try to take the midpoints and join them in order to get the whole unit cell, get this side here. So what I will do now, I will take the midpoints. So we take the midpoints here. So, and after that, same midpoints will be there for the down layer also. And I will join these lines. You can see that I am getting a kind of
hexagon.
Yeah, a kind of hexagon, and there will be 3 red atoms here also.
Red atoms means face centered, right?
No, no, no. These are completely inside the unit cell. देखिए, if I join these 2 lines, these are coming completely inside, है ना? So these are not in the face center. Okay. So these black atoms, these are in the face centers here.
So what is red?
What is red? Those are the B layer atoms. What do you mean to say what is red?
They are inside the
Yeah, they're completely inside the unit cell.
red ones.
The red ones are completely inside. They are not in the face centers.
Okay.
Okay, so these are not in the face center, they are completely inside. Okay, so this is hexagonal. This is also known as hexagonal close packing in 3D. Okay, and this is the unit cell. Hexagonal unit cell. Okay, now in this hexagonal unit cell, the first thing that we will discuss is the calculation of Z. Okay, first thing we'll discuss is calculation of Z. Now in this calculation of Z, it is not like Q, so we have to reconsider whatever we know about the contribution of each type of atoms. Okay, so first thing is that calculation of Z. Now in calculation of Z, number one is, what are the types of atoms that we can see? There are 3 types of atoms. The ones which are present in the corner, right? The black atoms, all those 6 black atoms and of the top layer and the down layer. Then we have the black layer which is present in the face centers. So this is the face center, this is the face center. And then we have all the red atom that is inside. Got it? Yes or no? Tell me.
Yes.
These are the 3. No? So first of all, let us see how many corner atoms are there. Tell me. Count and tell. How many corner atoms are there?
Corner atoms are 12.
What do you think? What will be the contribution of each?
1/8.
No, not 1/8, because it is not a cube.
Oh yes,
It will
it's
not
not a
be,
cube. Yes.
it's not a cube, right? So it will not be
Uh,
available. So what we have to do, we have to look at sharing. You remember? In cube
yes.
also, we first of all looked at what is the sharing of each of them. So for sharing, what you need to do, so you can see that I can extend this line like this. I can make a unit cell here and I can make a unit cell here, right? Can you see that?
Yes.
Okay. Make it properly. This atom will be shared in this one room, second room, and third room, correct?
Yes.
Similarly, there will be 3 rooms just above these 3 rooms, and this corner will be there in those 3 rooms also, correct? Yes or no?
Yes.
So it is shared in 6 rooms. Okay, so it is shared in 6 rooms. And that is why the contribution of each will be 1 by 6, which will give me 2.
2.
Correct? Now,
Yes.
phase center is here, and there will be 1 unit cell just above it. So the phase center one will be still, there is 2 phase center atoms divided by into 1 by 2, because their contribution is half, because there will be only one unit cell just above this unit cell, and the phase center atom will be shared in that unit cell also. So this will be equal to 1.
1.
Now inside atoms there are 3,
So
and all of its
face centered atoms in all shapes are 1 by 2, right?
they will be always 1 by 2 phase center atoms. Okay. Inside one will be always 1 because they're completely inside. So this will be equal to 3. And hence the Z is equal to 2 plus 1 plus 3, which is equal to 6. Is that right? Yes or no? Tell me.
Yes.
Okay. Now moving on to the coordination number. So we have this layer A, we have this layer B, and we have this layer A again. Okay. So for coordination number, I want you to focus on this particular atom. Okay. Can you see that?
Yes, sir.
So this atom here. So in this same layer, in the A layer, it is touching 6 atoms, right?
Yes, sir.
Okay. Now these red atoms, as you can see, they are just on top of this black atom, correct?
Yes, sir.
And that is why they will be also making a tetrahedral void. That means this black atom, if you look from downward, it will look like this black atom is sitting on these 3 red atoms. This black atom is sitting on these 3 red atoms. So now it is touching 6 in one layer, 3 in the above layer, right? Yes or no?
Yes, sir.
Now, similarly, after this A layer, there will be again a B layer, correct? In which we will be having again these 3 red atoms, right? And this black atom will
Yes.
also be touching these 3 red atoms. Got it?
Yes.
So we have 6 in the same layer. There is 3 atoms that is touching in the above layer and 3 atoms that is touching in the down layer. Okay, so the second thing is the coordination number. Second
It's
thing is
also 12.
coordination. This is also 12. Coordination number is equal to 12. Okay. Now the next thing is relation between A and R. But first of all, we have to see that there is not only A and edge length. There are 3 things here. We have this. You can say this is A. We also have this B. But A and B will be same, but that's different case. But we have something which is different, that is C here. Right? We have a height also. Yes or no?
Yes.
So we have A, B, and C 3 things. A, B, and C 3 things. Also, there will be now in cube we only had 90-degree angles, but in this case you can see that there is an angle between A and C that is equal to 90 degree. That is correct. There is angle between B and C that is also equal to 90 degree, but there is an angle between A and B which is not equal to 90 degree. Yes or no?
Yes, sir.
So next thing that we are going to study, this is the second point. The third point is cell dimensions. We did not study cell dimensions in the earlier cases because all of the cell dimension it was the length was edge length was A and the angle was all 90 degree. But in this case we have A, there is B, and there is C, and we have angles which are alpha, beta, and gamma. Now please remember what are alpha, beta, and gammas. So alpha is the angle between this alpha. It is the angle between A and C. Okay, so B and C. Alpha is the angle between B and C. And then beta is the angle between A and C. And gamma, we say that gamma is the angle between A and B. Can you remember this? So alpha is the angle between B and C. Beta is the angle between A and C. And gamma is the angle between A and B. Okay.
Okay, sir.
Fine. So this is how it is named actually. Okay. So alpha, beta, gamma. Now we can see that angle B and C. Okay. And angle A and C. So B and C, it is what? B is in the floor and C is the cell edge here as the height. So it is going to be 90 degree. So alpha is equal to 90 degree. Beta A and C is also equal to 90 degree, but the angle between A and B it is equal to 120 degree, right? So you can say here that alpha it is equal to beta, which is equal to 90 degree. And then we have gamma, which is equal to 120 degrees. Is that clear? Yes or no?
Yes, sir. Clear.
Okay, fine. So we have got the cell dimensions also. Now, the next thing is packing efficiency. So since we don't know, Achal, can you tell me what will be the volume of this hexagon? This hexagonal unit cell, what will be the volume? One thing is for sure, don't try to remember it, okay? Because you have not learned. But there is a way in which you can calculate the what do we say, volume for this piece here, this unit cell here. Tell me, no idea? Yes, Zaid and Hamza.
Yes, sir.
Sorry, no.
Yes, Zaid, you are saying something?
No, sir.
No. Okay. So when we were learning about HCP in 2D, we found out that the area of this hexagon, the regular hexagon that we have as the base layer, it is 6 into root 3 by 4
Yes, sir.
a square, right?
Yeah.
Now, as soon as we went to 3D, there was one more dimension which was introduced, which was the C, that was the height. So we have base, the area of base into height, that will give me. So this is the volume for this hexagonal unit cell. Got it? Yes or no?
Okay, sir.
I know. So when you have cube also, you can see in cube. I hope this idea is not new to you. That you have what is the area of this base? This base is a square that is equal to a square. And if you what is the height here? It is equal to a again. So the volume will be equal to a cube. So area of base into height is equal to the volume of the solid. You got it?
Okay, sir.
Hannah, I hope you have learned this in 10th standard, I think. Achha, you must have, but you may have been forgetting things, but you may have learned it also. Packing efficiency. So we are not going to derive the packing efficiency because it is not there in your syllabus and it is not required by you to calculate the packing efficiency, because you will need the relationship between A and R. We can have that relationship between A and R, but the relationship between C and R also you would have to find out. Okay, so that is why we are not going to derive this. The packing efficiency, you can just write it is equal to same as the previous one, 74%. The packing fraction, it will be equal to 0.74. The void percentage, this will be equal to 26%. Okay, so these are the three things that you need to write. Next is what will be the voids here? What will be the voids and the number of voids? Okay, so please remember we are talking voids in unit cell. Okay, voids in unit cell. So whenever we are talking about anything, we are talking about the unit cell here. So we have here octahedral void, and we have seen that it will be equal to n, that is the number of atoms. So what is the number of atoms in this unit cell? It is equal to 6. So the number of octahedral voids will be equal to 6, and the tetrahedral void, it is equal to how much? It is equal to 2n. So this will be equal to 12. Is that clear? Yes or no? Please tell me. Huh, guys? Is this clear?
Yes, sir.
Void. Okay, fine. So you need to write somewhere. Just let me know which part. Coordination number, cell dimension, or packing efficiency, or whites, or everything is done. Just let me know if everything is done.
So finished.
Okay. Now there is a question regarding the whites. Okay. Now this will clear things up for you. So you may write this question. Compound forms hexagonal close packed structure. What is the total number of whites in 0.5 mole of it? How many of these are tetrahedral whites? Write this question. Just let me know when you are done writing this question. Okay.
Okay, sir. So finished.
Now, first thing is that hexagonal close packing. 2D or 3D? Tell me. 2D
So
or 3D?
3D.
3D. Always 3D, because when they have not mentioned anything, that means it will be 3D. If we want to ask you about, they want to ask you about 2D, they will especially mention that it is 2D, because in general, in reality, in real world, everything is 3D. So we have HCP, sorry, we have hexagonal close packing structure, and in this hexagonal close packing structure, we know that there are two types of void. There is octahedral void, and there are tetrahedral voids. Yes or no? And what is the octahedral void? It is equal to n, and the tetrahedral void, it is equal to 2n. Okay. Everything is clear till here? Yes or no?
Yes, sir.
And what is n here? N is the number of atoms, correct? Please remember,
Yes.
n is always number of atoms. Here also n is number of atoms. So this is 2 into number of atoms. Now in the question, tell me, what are the number of atoms? Can you see that? How many atoms are there? That whole packing is made up of how many atoms?
So 6.
नहीं ना, कहाँ सवाल में कहाँ बताया हुआ 6 है, बताइए. तो see,
No,
they are
no. Sorry.
they're not talking about the unit cell. Please remember that. है ना? They're just saying that it is making hexagonal close packing. So that what amount of compound is taken? Tell me, how much is the compound? What amount of compound is taken?
So it is not mentioned.
It is not mentioned. So read this question. A compound forms HCP structure. What is the total number of voids in 0.5 mole of it? What is it here? The compound, no?
So, yeah, compound.
So what is the amount of compound given?
0.5 mole.
So we have how many atoms of the compound? 0.5 mole of atoms, right? Yes or no?
Yes, sir.
I know. So the number of atoms that they have given is 0.5. So there will be 0.5 mole of octahedral voids, and there will be 2 into 0.5 mole of tetrahedral voids. So total voids will be equal to, this will be 0.5 plus 2 into 0.5 will be equal to 1. So this will be equal to 1.5 mole. And out of which, how many of these are tetrahedral voids? So there are 1 mole of tetrahedral voids. 1 mole means 6.022 into 10 to the power 23 tetrahedral voids will be present. Is that clear, yes or no? Now you understand the difference between the unit cell and the packing.
Yes, sir.
So in unit cell, when we are talking about unit cell, so things are very specific there. Things are very specific there. Z is equal to this much. But in packing, we can take any amount of atoms and we can make any of these packings. Okay? So please write this down. Total is this much, and tetrahedral void, tetrahedral void, it is equal to 1 mole. Done?
Yes, sir.
Yeah. So now what we will do, we will summarize whatever we have learned till now, and this is going to be the crux of the things that you have to remember. Okay. So whatever I am going to write now, this is utmost important. This is the most important thing that you're going to see, and this is the thing that we have to remember. So first thing is initially we stated that there are 8 corners. Things about corner is equal to how much? Corner is 8. So these things you have to remember. You have 8 corners, right? And what do you have? You have 12 edges. You have 6 faces, right? The contribution of the corner atom, corner, edge, and face. So corner is 8, edge is 12, face is 6, and the contribution is 1 by 8. For edge, it is 1 by 4. And for face centers, for a cube, it is equal to 1 by 2. The other thing that you have to remember is about the boundary diagonal and the face diagonal. So face diagonal, length of face diagonal is equal to a root 2, and the length of body diagonal, it is equal to a root 3. Okay, so these are the, what I can say, prerequisites that you have to remember. Then we talked about the voids. Okay, so for void, you have to remember in 2D and 3D, there are 2 2D voids, there are 3 3D voids. Then we went to 1D packing. So 1D packing. Now there is only one question that can come from 1D packing, and which is the, what is the coordination number? So we will write just the coordination number of 1D packing, it is equal to 2. Now these information are prerequisite. Just make a square bracket along with it. Okay, so this is 1D packing. After that, we went to 2D packing, and we saw that 2D packing can be of 2 types. 2D packing can be of 2 types, and those 2 types were, just wait a second. 2D packing can be of 2 types. So those 2 types were the square close packing in 2D, and there was hexagonal close packing in 2D. Hexagonal close packing in 2D. Now, when we went from a square close packing 2D to 3D, we saw that we can make 2 different types. Now, in HCP, you have to remember packing efficiency is 78.5%, and HCP, the packing efficiency is 90.6%. Now, please listen here, don't write now. Okay, I will give you time to write. Please don't write now. In SCP, we saw that we can have 2 types of structures. One is simple cubic and the other is body-centered cubic. One is simple cubic and the other is body-centered cubic. Simple cubic and the other is body-centered cubic. Now in HCP, we saw that there are 2 types of voids. So we can have a upward facing and a downward facing. And after this, if I add atoms in this will convert into tetrahedral voids made by layer B by the new layers, and this will be converted to octahedral voids. So if I add atoms on tetrahedral voids, I will get which kind of cell? We will get HCP, the AB type. And if I put atoms on octahedral void, I will get FCC, that is the face-centered cubic. That is the face-centered cubic. Okay. So now for this, I will be doing, I'll be writing the Z and all. So it's what ठीक से बनानी. Wait a second. Let me draw this once more. We have 1D, then we have 2D, in 2D we have 2 types. There is square close packing, there is hexagonal close packing in 2D. From SCP, you have to remember that the packing efficiency is 78.5. And for HCP, the packing efficiency is 90.6. Then from SCP, we went to 3D, and in 3D, we found that there are 2 different ways in which we can arrange the atom. One is simple cubic, the other is body-centered cubic. On SCP, we saw that there are 2 different types of voids, an upward facing and a downward facing. If I put atom on this will be converted into tetrahedral void, and there will be a new tetrahedral void made by layer B. If I put atoms on this tetrahedral void, I will be having a HCP, which is 3D. And if I put atoms here, this will get converted into octahedral void, and we will have face-centered cubic. Okay. So now we need to write a few things regarding all of these different unit cells. So we'll be talking about the Z. First of all, let me make some lines. So we'll talk about Z. Then we will be talking about the coordination number. Then we can talk about the. Then we can also talk about the relationship between A and R. Then we can talk about the packing efficiency for both of all of this. And what else? We can also talk about the voids. Now we can also talk about the voids. So you have, first of all, is the Z, then the coordination number. Okay, and after that, relationship between A and R. After that, we have the packing efficiency. And then we will talk about the voids. Okay, so please open your notebook now. Don't write anything, just answer me. Okay, both of you, Hamza and Zain. Please turn the mic on. Acha, wait a second. Let me just get my earphone. Yes. Please turn your mics on. Yes. Okay, Hamza.
Yes, sir.
What is the Z for simple cubic? Please look at your notebook. Hai na? Flip some pages and tell me Z of simple cubic. Yes. What is the Z for simple cubic, guy?
Z is 1.
Z is equal to
1.
1. What is the coordination number?
Coordination
simple-
number of simple.
Coordination number of simple cubic is?
It's 4.
नहीं नहीं नहीं, देख के बताइए ना, ऐसे क्यों बोल रहे हैं आप लोग? Just look and tell Zaid what happened.
So should I also tell?
हाँ, both of you.
Okay.
Coordination
Then,
number है?
so okay. Coordination number is
Sir, it's
I think
6.
4 or not.
Yeah, it is 6.
6.
What is the relationship between A and R?
The relation between A and R is
A equal to 2R.
Yeah, A equal to 2R. Packing efficiency?
52.4 or
Yes.
yeah.
52.4%. And what is the void in simple cubic?
Voids are cubical void, I think.
Cubical void, yeah.
Yeah.
There is a cubical void. Okay, for BCC now tell me, body centered cubic, what is the Z for this?
Z is 2.
Coordination number?
8.
Relationship between A and R?
A root 3 equal to 4R.
A root 3 is equal to 4R.
Hmm.
What is the packing efficiency?
68%.
68%. And the void, you don't have to remember the void, okay? So it is
Yes.
distorted octahedral,
Distorted
but you
octahedral.
don't. But ये आपको याद नहीं रखना है, ठीक है? Now for
Okay.
HCP, what is the Z that we learned just today?
HCP for
The one
cubic
that
close
we did
segment.
today. HCP नहीं. HCP hexagonal cross packing 3D आज जो पढ़ा है आज.
Sorry. It is 6.
6. Yeah. And the coordination number is
12.
12. So we don't have to put the relationship between A and R, है ना? Because we'll have A, B, and C. Packing efficiency is
74%.
74%. And void is
26%.
अरे नहीं voids कौन से voids हैं? So there are
Sorry.
six.
ये लिखा
There
है।
are 6 octal void. नहीं लिखा कैसे नहीं? ये नहीं लिखा अभी ऊपर वाला. This part here, voids in unit cell.
Sorry, we have note किया है। Octahedral void 6 होते हैं और tetrahedral void 12 होते हैं।
There are 12 tetrahedral voids.
Yeah.
12 tetrahedral voids, है ना? And
Yes.
FCC में face centered cubic that we learned yesterday.
Z is 4.
Okay. Coordination
Relation
number?
with coordination number is coordination number 8. I say coordination 12. 12. Sorry.
No, for this also it is 12. And the relationship between A and R?
A root 2 equal to 4R.
Yeah, A root 2 is equal to 4R. Packing efficiency is same, 74%. And the void is 4 octahedral voids are there.
4 octahedral void and 8 tetrahedral void.
Tetrahedral voids. Okay. So please make this chart. Anna. Now, what if anything that is present in this chart, you have to remember it. Okay. So each and every point that is present in this chart, you have to remember it. And this is the summary of whatever we have done from 9th till today. Okay. 9th till today, whatever we have done, it is a summary of everything right now. Okay. So we have not included the voids, especially here, but you can see octahedral void, tetrahedral void, cubical void, everything is mentioned at least there. Okay. Chali. Please copy this down. Let me know when you're done.
Okay, sir.
Done?
Yes.
Both of you are done? Okay, fine. So now I will discuss a very small portion, which is the concept of nearest neighbor. Okay, concept of nearest neighbor. I will start with simple cubic structure. Okay, I will start with simple cubic. Number 1, in simple cubic unit cell. Okay, so in simple cubic unit cell, so let me make that simple cubic unit cell first of all. In simple cubic, we have atoms in all the corners only, right? Yes or no?
Yes.
Okay. So if let us take this black atom here, है ना? So there are 3 neighbors to it. A neighbor here, this neighbor, and the neighbor which is downside. All of these are what? All of these are how much distance away from the black atom? A distance away from the black atom, right?
Yes.
So this is the first nearest neighbor, or this is the nearest neighbor. Okay, so this is the first nearest neighbor, or you can write it as the nearest neighbor. So wait a second, let me make a chart. Array, what happened? First neighbor, second neighbor, and third neighbor only there will be there. Yeah. So here what I will be writing, the simple cubic. Then I will be writing the distance. Okay, and number. How many are there? Okay. Fine. So first of all, I will see the first nearest neighbor. Okay, first nearest neighbor. Acha. Can I write it as NN? Nearest neighbor as NN. Okay. So first nearest neighbor. So the distance of the first nearest neighbor is what? It is A. Yes or no?
Yes, sir.
Now, please remember that this nearest neighbor, na, in this unit cell, it is how much? It is 3, and there will be one here also, there will be one here also, and there will be one here also, right? All of these atoms will be neighbors to this black atom, correct? Yes or no?
Yes, sir.
So the total number will be how much? The total number, see, this will be 6. Okay, this will be 6. Now, moving on to the second nearest neighbor. So let us move here. So if I go from here to here, I am here now, and then I find the next nearest neighbor is this one. Yes or no? This atom
Yes,
is the
sir.
next nearest neighbor, right? So this will be how much? Next nearest neighbor will be A root 2. That is the phase diagonal distance from here to here. Correct?
Yes,
Yes
sir.
or no? Hana? And how many will be there? There will be 12 of this. Okay, there will be 12 of this. So you can see that in one unit cell. So this is one black atom. So it is touching this one, Hana? And there will be this face also, and there will be this face also. So in this whole one, it is touching how much? It is touching how many? 3, right? So you will have 8 unit cell, and in 8, all of this 8, there will be 3, and then you will have to divide this by 2. You will have to divide this by 2 because these atoms will also be there in some of the unit cell. Okay, so it will be also shared in this unit cell here, which in this atom will also be present. So that is why it will be equal to complete equal to 12. So this will be equal to 12. The number is equal to how much? The number is equal to 12. If I want to calculate the third nearest neighbor, then third nearest neighbor will be the bodies from the body diagonal here. So this will be A root 3, right? This will be A root 3. And there will be one body diagonal here. There will be another body diagonal there. So in each of these 8 unit cell in which this black atom is being present, in all of them, there will be one corner, I can say, which is opposite to it in a body diagonal fashion, and this will be equal to, total number will be equal to 8. Okay, so when you have the first nearest neighbor, so first nearest neighbor 6 ऐसे आया है. You have 8, right? 8 unit cell, and in each of these 8 unit cell you have 3, but you divide this by 4 because each of these corner atoms, it is, so these two corner atoms are shared by 4 unit cells, है ना, because ये edge में है. Can you see that? Yes or no?
Yes.
है ना? So this is inside an edge, and this edge is shared by 4, right? This edge is shared by 4. That is why this is equal to 8 by 3 divided by 4, which will be giving you 6. Okay, so the number of atoms that is first nearest neighbor, it is equal to 6. Okay, so don't write this one. Don't write this. Let me just copy this for the BCC structure. Things will not be same here, so I will change these things. Second is body centered cubic. So these things will change. You have BCC now. Okay, now in BCC, let me make a BCC unit cell first. I can erase some of these things. तो सारा इमेज जाएगा फिर. I think I have to make it from starting only. We have atoms on the corners. And then we have one atom in the body center. So if you remember the BCC structure, then you know that these are the atoms which are touching each other. Let me wait a second. So these are the atoms which are touching each other, right?
Yes.
In the body diagonal. So the nearest atoms are these two. Yes or no?
Yeah.
Correct. So the distance, you can see that the whole body diagonal will be a root 3, right? The whole body diagonal will be a root 3, and that is why half of a root 3 will be a root 3 by 2. Correct? Yes or no?
Yes.
And you know that this atom is touching this one red atom. Also, this black atom is touching 8 red atoms in the 8 unit cell. So the number will be how much? The number will be 8, because you also know that this red atom is touching all the 8 corners, right? Yes or no?
Yeah.
And the black atom is touching the 8 body centered of different 8 unit cells. Now second will be, you have this A from here to here. This is your next nearest neighbor, which is equal to A. So this will be equal to how much? There are 6 here. One from here, one from here, one from here. There will be 6 like this, है ना? So corners का आपको पता है that you have 6. ये erase नहीं हो रहा है. Then the next nearest neighbor will be this one from the face diagonal, which is a root 2. And we have seen that earlier. How many a root 2s can be there? There will be 12. Okay, there will be 12. Is that clear? Yes or no? Tell me.
Yes.
Okay. Now moving on to the third thing, that is FCC. एक काम करते हैं, इसी को ले लेते हैं. Then we have the blue atoms I can take. So one face center here, one face center here, one face center here, one face center here, and one face center will be here also. There will be one face center here. Okay. So in FCC, the atoms that are touching each other are the atoms that are touching each other. Those are which atoms? Those are the atoms in the phase diagonal. Yes or no?
Yes, sir.
Okay, what is happening? Wait a second. Let me. Fine. So the first neighbor will be from here to here. So this will be equal to how much? A root 2 by 2. Correct? Yes or no?
Yes.
Hai. Now this particular atom, it will be touching this atom also. It will be touching this atom also. This will be touching this atom also. And this one corner, it will be present in 1, 2, 3. And similarly, it will be present in 12 more. What I can say, it will be present in this phase center also. This phase center also it will be touching. This phase center also it will be touching. This phase center also touching. So in total, you will see that it is touching 12 phase center atoms. Okay, so the number will be 12. Now the second will be again this A here. That is the second nearest neighbor, and there are 8 A's that it will be touching. 8 hoga. Wait a second. Is this not working? ये तो काम कर रहा है, इरेजर क्यों नहीं काम कर रहा है? Let me reshare this thing. Acha, let us write first, okay? A, and after that you will have third, that is A root 3 by root 2. Okay, so I will explain this A root 3 by root 2 after I am done with iftar and maghrib. Okay, and there will be 24 atoms that will be a distance of far away, that is A root 3 by root 2 distance far away from this corner atom or any of the atoms. Okay, so just
Okay,
write
sir.
these 3 and then I will be back after iftar. Oops, sorry. I needed to mute Yes, hello. You guys are done? Yes, Hamza and Zaid.
Yes, sir. Yes, sir.
Okay. Okay, fine. Acha. So, anything specific in here that you need to, you want to understand a bit?
So I want to understand in BCC third one.
ये FCC है, sorry, हाँ, ये वाला
Yeah, sorry. Yeah.
FCC का, sorry, FCC is third one, okay. So in the FCC third one, so अच्छा यहाँ तक आपको समझ में आ गया. Then we have to look at the next neighbor. Okay. So what do you think will be the next neighbor? Tell me. First neighbor is this one. This is my first neighbor. Second neighbor is this one. Okay. What will be my next neighbor?
Okay.
What will be my next neighbor? Just by looking at it, tell me the corner atoms or the face center atom, which one?
Face center we have done I think corner atom.
Corner atom. So you think that, let us suppose this atom is what? The next neighbor?
Yes.
Okay. But actually there is, if you see and you make a line like this, coming from this atom to this atom. Okay, so this is your front wall, and in the this corner is at the top left corner of the front wall, and this blue atom is this blue atom here, which is in the face center, is at the back wall. Okay.
Yes, yes.
Okay. So here we have the corner atom. Now इसको black कर देते हैं. Okay, and then here we have a blue atom which is on the face center of the back wall. Okay, yes or no?
Yes,
Fine
sir.
till here. Okay. Now then I'm making this yellow line. Please see this. Okay, so this is on the cell edge, right?
Yes.
Now, and then what I will do, I will make a line like this. So from the cell edge, what it is going, it is from the middle of the cell edge, it is going directly towards the face center atom that is present in the back. Can you see that?
Yes, sir.
And if you orient it in a different angle, you will see that it is a right angle triangle. Correct?
Correct.
Okay. Now, if you see this one, let me take some different color for this. Let's take red for this one here. Okay. So if you see the yellow line, it is half of the cell edge, right? A by 2.
Yes, sir.
Okay. And if you see this red one, this red line here, it is half of the face diagonal. वो कैसे होगा? देखिए. If I would have extended this till here, and if I would have made this till here, this will be the face diagonal, and you can see that there is shadow of half of the face diagonal. So this will be a root 2 by 2. Correct?
Yes, sir.
And this is the distance. So you want to find out the distance. So the distance is equal to distance square. It will be equal to a by 2 whole square plus a root 2 by 2 whole square, right? So this will be equal to a square plus root 2 a square will be equal to 2a square whole divided by 4, right? Yes or no?
Yes, sir. Yes.
Anna? Okay. Then what do we have here? We have here 3a square. अच्छा सॉरी ये 4 नहीं होगा, a square plus a square 4 हाँ ठीक है 4 हो जाएगा, ठीक है, a by 2 and a root 2 by 2 ना. So this will be equal to 3a square by 4, right?
Okay, sir.
है ना? So actually ये यहाँ पे root 2 नहीं होगा, this will be a root 3 by 2 only, a root 3 by 2, ठीक है? So this will be, if you calculate the distance, this will be equal to under root of 3 a square by 4, which will be equal to a root 3 by 2. Okay?
Okay, sir. Sir, I think time हो चुका है तो आज